So I apologize, there was a typo on your lesson sheet. Wouldn't be a normal day if I didn't have a typo in one of your lesson sheets. So this was originally an X. Change this to a 0, and that's going to change the problem quite a bit. So again, change to a 0, not X. Okay, so change that on your sheet if it's not already done already. Okay, so that's going to make, when we subtracted 3 from both sides, now I'm going to have 0 minus 3. That's negative 3. Okay, and so when I go to square both sides to get rid of this radical, I now have 5x minus 1. It's the square root of something squared. Inverses, so I have 5x minus 1 equals negative 3 squared is positive 9. Okay, so now I'm going to add 1 to both sides. 5x equals 10, and x equals 2. So before we box it, get into the habit of checking your solutions. So when I check, checking always means take your solution, plug it back into the original equation, and see if it makes a true statement. So I'm going to plug that in. 5x is now going to be 5 times 2 minus 1 plus 3 equals 0. And we're going to see if that's true. So I get the square root of 5 times 2 is 10, minus 1, that's 9, plus 3 equals 0. The square root of 9 is 3, so I get 3 plus 3 equals 0. 6 equals 0. That is not true, so that is not a real solution. So not true. So we're going to say no solution. So if you check it and it doesn't work, it's no solution. Another thing you need to look out for is if when you get your solution, if you plug that back into the radical, into the original equation, if you end up with a negative number under a square root sign, that's also going to result in no solution because you can't have a negative number under a square root sign. No number squared is going to give you a negative number. Okay, so example 5 says solve and check. Now, it says that if an equation contains 2 radical expressions, like this, or radical exponents, that should actually say, yeah. So isolate one of the radicals or exponents. So what I'm going to do is I have the square root of 3x plus 2 minus the square root of 2x plus 7. So I need to isolate them. I need to get them on opposite sides of the equal sign. So what I'm going to do is just add the square root of 2x plus 7 to both sides. And that's going to give me the square root of 3x plus 2 equals the square root of 2x plus 7. Now, conveniently, I have a square root on both sides. They're both isolated. So if I then square both sides, this is legal because I'm doing the same thing to both sides of my equation, the square roots go away. So I get 3x plus 2 equals 2x plus 7. And now I can solve for x. I'll subtract 2x from both sides, leaving me with x plus 2 equals 7, and x equals 5. And I do want to check, make sure that works in the original equation. So plug in 5 into the original equation. So I get the square root of 3 rather than x, it's 5, plus 2 minus the square root of 2 times 5 plus 7 equals 0. So this gives me 3 times 5 is 15, plus 2 is square root of 17, minus 2 times 5 is 10, plus 7, 17. And I have the square root of 17 minus the square root of 17. Anything minus itself is going to be 0. So that one did indeed check. And at no point did I have a negative number under my radical. Okay, and that is it for today. So go ahead and start your practice problems.